Deadlocks are really a true condition, and they really exist, and so we are supposed to deal with them. So we are supposed to handle them. So what are the various deadlock handling mechanisms that are right now used at practice? Or first, the simplest one is deadlock ignorance, and this is the most popular one, and is used by Windows and Linux. So both Windows and Unix, they are going to use this method of ignorance. Ignorance means we act as if there is no deadlock at all. Even though it is true that deadlocks are possible, we act as if it is never possible, right? And what happens because of that? There will definitely be deadlock in your system, and because of which your system will halt. Then users, they will wait for some time, and and then they don't understand what is going on in the system, and simply they will restart it, and they will go ahead with that. And why such a mechanism used is this ignorance. The reason is, in order to use any other handling techniques, we need to write lot of code, and then we need to spend lot of time on dealing with these problems with lots of restrictions, and moreover, and all of this is going to hurt the performance. And as a user, I mean, if it is not a mission critical job, and if you are doing if you are a normal user who wants your computer to just for browsing and then doing some personal stuff, then you will not be too much worried about the deadlocks, which means you will be happy if your system runs faster compared to your system runs safer, right? So there is a trade-off. Mathematicians argue that deadlock should be handled, but engineers argue that since deadlock is a rare condition, which means once in 5 years people will come across this problem, therefore we'll handle the other problems, like if every day if some problem is going to arise, right, then we'll handle that problem first rather than handling a problem which occurs once in 5 years in a computer, right? So that is how many of the practical operating systems, the end user operating system these days, they are just ignoring the deadlock. I'll tell you an example. Let us assume that we have 10 process in our computer, and each process requires that they for 10 sub process. Therefore 10 running process wants to produce 10 sub process each, and totally combined it is going to be, I think 110 process. That is what the system requirement is. Let us assume that at some point in time 10 processes are running, and each of these 10 processes want to start 10 sub processes, and therefore the total number of processes that can be present in the system at maximum are 110, right? And now at this point assume that we need 110 process to be present in the system, so that all these processes will get complete their execution. But then assume that our process table, I'll tell you later what the process table is. The process table will contain one entry for each process that is going to be present in your computer. The process table is big enough so that it can handle only 100 processes. Now I need 110 process to finish my job, but I have only space to hold 100 processes. Assume a scenario where all of these 10 processes have produced 9 sub processes each, and therefore 90 plus 10, original 10 plus 90 sub process, totally 100 processes are now completely present, and they have taken all the space slots. Now all these processes, all these 10 original processes, in order to finish their execution, they need to have one more process, right? Because each one needs 10 processes, which means we need 10 extra slots, and every process needs one extra slot. Therefore they all will be waiting for the extra slots, and they all will go into the deadlock. How can you ensure that such a deadlock will not occur? Only thing is, you should restrict the process in such a way that at any time only one process can apply the fork. If more than one process applies the fork, then what happens is, I mean, if two processes are allowed to use the fork, then what happens is two processes will keep on filling up the process table slot, right? And suddenly what happens, there will be no space, and therefore these two processes will wait for each other to finish their jobs, and therefore they will get into deadlock. Now restricting that at any time only one process uses the fork is a very high restriction, very big restriction, right? And it is going to hurt the performance, because many of the systems, many of the process want to apply the fork randomly. We cannot say that at any time only one process can apply the fork. Even in order to do that, you have to maintain lots of data structures, and you have to keep track of what are the process running, and what is the code they are using, and in case if they try to apply the fork, you should block the process. It is all going to be a headache. And this deadlock is a very rare condition in normal users in such a way that if you experimentally, it has been found out that it is a condition which occurs once in 5 years. Now, in order to handle that case once in 5 years, you have to write a lot of code and you have to create a lot of inconvenience to the users. Instead of that, what many engineers did is they simply ignored it. That is how Windows and Unix, they don't handle it at all. They just ignore it. They act as if nothing is going to happen. I mean, there is no deadlock at all. And sometimes this method is also called as ostrich approach. Ostrich is a bird. You know that, right? The ostrich is a bird with long neck and which cannot fly. I think the biggest bird in the world. I think yes, right? And how will this ostrich attack this problem of this sandstorm is, whenever there are sandstorms in the deserts, this ostrich will just stick its head into the sand. It will put its head into the sand, and it will close its eyes and act as if there is no sandstorm, right? That is why it is it is comparable to this deadlock approach. So it is also called as ostrich approach, which means we act as if there is no problem, like the same way how ostrich is acting as if there is no sandstorm, we are acting as if there is no problem at all, right? But the actual case is deadlock is real, we have to handle it, but then there is always a trade-off, correctness versus performance. So we are going to prefer performance, not the correctness, right? So at some point of time, definitely users will get struck, some process will get struck and no work will get done. Then what is that users will do is again restart. They shut down the system and restart it, right? So that is how the deadlock ignorance is going to work. And then the deadlock prevention method is, prevention, prevention is better than cure. We'll see that deadlock will never occur in our system at the first place. How could that be done? Now, if you want to make sure that something doesn't happen, just disable all the necessary conditions, or at least one of the necessary conditions. For example, I've shown you that there are 4 necessary conditions for deadlock. Now we shall take those 4 necessary conditions and then we shall try to disable at least one of the necessary conditions. If you could disable at least one of them, then definitely deadlock will never occur, right? So if the deadlock is not occurring at the first place, you need not deal with it at all, right? So one way to handle the deadlock is don't let it happen at the first place. That is called as deadlock prevention method. And next one is deadlock avoidance. So deadlock avoidance is, we'll try to avoid it in the sense there is a chance of getting the deadlock, but then we'll at every step we try to avoid it. Two things, one is safe state, other is unsafe state. So I'll again show you this, but just I'm trying to introduce you here. So deadlock avoidance, in order to do this, I'll try to find out whether this system is in the safe state or unsafe state. I mean to say safe, S-A-F-E, safe state or unsafe state. So safe state means now the system could, all the process could somehow run with the available resources to the completion. Unsafe state means there is no safety, which means the process which are present in the system, there is no way you could allocate the resources so that it will run to completion. They will run to completion. Now we'll always see that our system will never go out of the safe state. Okay, forget it. I don't think that you understood it now. I'll take example and explain it. Okay, so forget it. So what I mean to say by deadlock avoidance is, at every step, whenever we allocate the resources to a process, we'll just be sure that this allocation will not lead to the deadlock. That is what I mean, right? So whenever you try to allocate resources to the process, we just see that this allocation will not lead to the deadlock. Got it? And next one is deadlock detection and recovery. See, deadlock ignorance is the most widely used method. And then deadlock prevention is possible, but then it has got some glitches, and deadlock avoidance also has got some glitches in the sense, I'll tell you that. But then deadlock detection and recovery is the next most popular method, which means we let the process get into deadlock, and then once they get into deadlock, we periodically try to detect the deadlocks, and then we shall try to do some methods to recover from them. So that is what. So now the main challenge in this is, how are you going to detect the deadlock, right? See, Here you need not do anything, deadlock ignorance, just ignore it. And deadlock prevention, yes, we need to do some work, like how can we disable the 4 necessary conditions, one of the 4 necessary conditions. And deadlock avoidance, here the main challenge is how are you going to find out what is the system state, which means is this a safe state or unsafe state. Depending on that we shall allocate the resources. But the problem is predicting the requirement of the process well before they run is a problem here. So that is a glitch. Okay, I'll talk about it later. And deadlock detection is I can say is the most practical method, which means let them go inside and then get into deadlock, and then I'll see that they are in deadlock, and then I'll do some of the methods, recovery methods, right? Okay, what I shall do is I'll take each topic individually, and then I'll explain you how to deal with each one. Okay, fine.